Why are the low frequencies so important when dealing with impact sound insulation in timber constructions? That is walking sound from your neighbor. It's probably something that you've heard about, that could be an acoustic challenge. I'm going to demonstrate why here. Here you have two typical dwellings. This is living rooms. They have the same single number quantity. And you can see a wooden one in blue and a concrete one in orange here. You see they have quite different characteristics. The concrete has its top level. Let's change this one instead. Around here is where you have the highest sound pressure levels in the concrete construction. Oops. And the wooden, it's another. It just keeps going up. So the lower the frequency, the higher the impact sound level here. This is the sound pressure level that you hear in your room when your neighbor is walking on the floor above you. And when you compare the measured impact sound level in a dwelling to the functional requirements that you have to fulfill, you, in Sweden at least, and more countries are also adapting this, you use this term, LNTW plus a spectrum adaptation term. So usually you measure impact sound insulation from, it's around here. You look from 100 hertz and up. And in Sweden we went a bit lower, so we go down to 50 hertz. And it's actually to a large degree because of we built a lot of timber constructions all the way back into the 1990s. The key issue here, there's some mathematics here, of course, but what this is pretty simple actually. This is just logarithmic addition of third octave bands. That's just what it is here. Logarithmic addition of third octave bands, because when you measure the impact sound level in the receiving room, you measure in third octave bands. And that means that let's forget about the concrete one now and focus on the blue one. In third octave bands, this would be let's say we do it as a bunch of bars like this. We go all the way down and so on and so forth. So if you were to divide this graph, it's actually a number of bars, like a bar graph in Excel. Now when you do logarithmic addition, what you do is that you take the first one. Oh, actually there's one more here and one more there. So if we were to now sum this one, we're looking at from 50 hertz and up, you would take the first one, which is 57-ish, that one. I'm just guessing now, 57, 58, 56, 55, and so on. And down here you're looking at levels around the 40 range, and here is the 30 range. So you see it goes down and it goes down up here. It's a 5, like so. Now when you start doing logarithmic addition, if the difference between two of the terms is more than 10 decibels, the quieter sound pressure level will have a negligible effect on the total. So what that means is that when you entering this high frequency region, they won't have an effect on the total. So it's this area is what determines the total when you do logarithmic addition. You can even try this if you pull up an Excel sheet and start doing some logarithmic additions of a curve that looks like this. And you will find that you can even discard this part of the curve completely when you do this addition, and you will still get almost the same result. You're only on the 10th of a decibel maybe that you get some changes, but that does not matter in the complete scheme. So that makes these frequencies very important. And that's because the curve looks like this. It goes from high levels here in the low frequencies, and then it becomes quieter the higher you go. And that means that it's only this lowest part that will have the significant effect on the total. And also there's discussion to even increase the frequency range even further below 50, 40, 35, maybe 25 or even 20 hertz. And you can see what happens then. These bars are even higher than here we are 70 plus dB at the 20 hertz. And that means when you add 20, 25, and 31.5 hertz, these three together will be up in perhaps in the 80 range. And that means you could even get rid of most of the curve. This little part will determine everything if you were to increase the frequency range. Of course, you can modify this with different frequency weightings and such, but with this current way of evaluating, this is just there's a linear frequency weighting all across the spectrum. We do our logarithmic addition of third octave bands, and that's it. And that's why you have to focus on the bars that are the highest. Those will determine the end result. And there are some other special issues when dealing with wood, which would be a good topic for another video that makes it even more fun to work with. So, well, that's it on the acoustic crash course for today. And in today's video, I'm actually wearing outer clothes because I'm on the way to the store now and pick up some groceries. So gone with a V-neck pullover, orange tie, white shirt, this old man's cap. I don't remember what they call it. Gubbcaps in Swedish. Brownish reddish leather jacket. I like this one. I bought it in India actually. It's quite a story behind this jacket. Some green pants, blue socks, and brown brogues, which I pick up in the watch once again. So it's a pretty good match, this. And I also remembered here a little good tip. When I'm out traveling, I always keep this one handy in my business bag, in the side pocket like this. So when I'm at a hotel room or whatever, I can always slip into my dress shoes, because that's a problem if you've ever tried doing it without. And there's not all the hotel rooms, they don't have the shoehorn. So get a travel shoehorn. It's a very good investment that will save your shoes and your fingers. See ya.